So the natural question that emerges is, what is the big deal? Is it just faster data? What does LTE bring from a technical perspective that impacts how we use the phone, as well as how we might think or design applications that run on the phone? Let's run through a few of the key changes that LTE brings to the mix. First, and probably the most important, LTE makes data a first-class citizen. This statement might seem a bit obvious with today's smartphones, but if we look back at how 2G and 3G evolved, data was actually just bolted on rather than being viewed as a foundational property. Hence, data access would often defer to the voice network at the cost of widely varying quality of service on the data plane. If anything, since the introduction of LTE, data has become even more important, whereby voice is viewed as an add-on rather than the primary rationale for the network. Although the ability to experience excellent calls is unlikely to fade anytime soon, technology such as VoLTE, Voice over LTE, which makes phone calls more Skype-like and extremely tempting to a carrier to embrace. Challenges, though, remain on maintaining key metrics and what happens when you enter mixed networks with Wi-Fi and cellular and the roaming that might occur between them. Second, latency has been dramatically reduced in LTE, to where the latency is not only much lower but much more consistent. The jitter, or changes in variation on a data link, can absolutely play havoc when data flows need consistency in behavior. Video, audio, and gaming are just a few of the applications that often require low jitter to remain functional. Inconsistency in latency and delay are quite perceptible by the user and lead to dramatically reduced quality of experience, not to mention limiting the types of applications the designer might come up with. Notably, though, considerable challenges still remain in the cellular space. While the total available bandwidth has dramatically increased, our demand for data so far has outpaced the ability of operators to offer service. A recent forecast by Cisco predicted 1,000x growth over 10 years. Basically, mobile traffic is going to double every year for the next 10 years, or something that we call the wireless data tsunami. Further, although we have gotten fairly good at coverage, and to a large extent 4G services approach reasonable Wi-Fi speeds, ultra-dense venues continue to be a problem. Whether it is sporting arenas or classrooms, they suffer under both Wi-Fi and cellular. I'm sure many of you have been in arenas where you see full bars on your smartphone, but yet you can get absolutely no coverage. You can see the tower great, and you see a full 5 bars, but you're sharing that uplink now with tens of megabits of capacity with 80,000 of your closest friends. The good news is that the new LTE standards are working on it with a technique called small cells. The bad news is that it takes time for those standards to get out to the marketplace and to actually deploy small cells. Finally, one last challenge is that while cellular does a great job oftentimes giving us coverage pretty much everywhere, it would be really nice to know where that is exactly. Because now it's not just enough to have data, we would like to know where we are in order to customize our experience or the data sensors that are around us. While GPS and cellular and even Wi-Fi can get us fairly close, within a room or two, we need something better, which is where the Internet of Things will come in during one of our last set of modules.